In this video, we'll learn about resource pools and VApps. Resource pools are a container object that are used to group together virtual machines for a few different purposes. The primary purpose is to assign resource controls on a wider scale. So we can use resource settings like shares, limits, and reservations to control prioritization. Right? Certain VMs, we may want them to get more memory than other VMs or get higher priority access to memory or CPU, right? And in those cases, we're going to give VMs a higher number of shares. Or if we want to place a cap on a certain resource for a VM, we can do a limit. Or if we want to guarantee certain resources to a VM, we can assign a reservation, right? But these resource controls become a little bit unmanageable if you continue to try to control them at an individual virtual machine level. So as your environment scales up, you may want to take advantage of resource pools in order to apply a set of controls across a wide variety of virtual machines. That's really what resource pools are all about, is to allow us to create these resource controls across a group of virtual machines. Right? So maybe we need to guarantee performance for some critical VMs, or we want to create a resource pool where we set some kind of memory or CPU limit for non-essential workloads. There's all sorts of use cases that we might use resource pools for. We can also apply access controls on a resource pool. So for example, let's say you create a resource pool and it's got all of your database virtual machines in it. Right? And maybe we'll give it a high number of shares because we want these database VMs to perform really well. Maybe we'll give it certain reservations to guarantee it a certain amount of resources. We can also apply access controls at the pool level. And those access controls will be applied to all of the virtual machines within that pool. Right? So for example, let's say we've got a group of database administrators and we want them to be able to open consoles to all of these database VMs. And we want them to be able to power them on and off and install VMware tools and so on and so forth. Well, what we can do is we can give them a permission at the resource pool level, and they will get that permission on every virtual machine within that resource pool. Okay, so resource pools are a nice way to conveniently control permissions as well. Okay, so let's take a look at an example of a resource pool, or actually two resource pools. So here in this image we have an ESXi host with 48 gigs of memory. I've got a group of development virtual machines on the left and a group of production virtual machines on the right. And if I'd like to, I can take those dev virtual machines and maybe place them all inside of a resource pool. And that resource pool can be used to set a memory limit. So maybe at any given time, I do not want the development machines to use more than 16 gigs of my host memory. I want to make sure at least 32 gigs is available at all times for other things. So I can place those dev VMs in a resource pool, put a memory limit on it, and I've just controlled the entire amount of memory that those virtual machines as a whole are able to consume. Or I could do something a little bit more flexible, like assign a share structure to the two pools. So in this case, I'm not putting any kind of hard and fast limits or reservations out there. What I'm doing is I'm saying, you know what, the dev pool is less important than the production pool. So maybe I'll give the dev pool 2,000 memory shares. I'll give the production pool 4,000 memory shares. And if my ESXi host happens to be running low on memory, if I'm in a scenario where there is memory contention, well, based on my share structure that I've identified here, the production resource pool will get twice as much memory as the dev pool. That's only going to happen if the ESXi host actually has memory contention occurring, if there's actually a shortage of resources, that's the only time those share values are actually enforced. Right? So this is a more flexible model than the kind of hard, strict limits and reservations. And so during times of contention, here's the allocation of memory that each resource pool would get. The dev pool would get 16 gigs. The prod pool would get 32 gigs based on their share values. I can even create a child pool within a resource pool, put certain virtual machines in that, and give that child pool shares, limits, and reservations. And what will happen is the child pool will actually draw upon the resources of its parent pool, right? Just like these virtual machines draw from the resources of the parent pool. And then finally, I could also give my resource pools a reservation. So I could say this production resource pool is guaranteed at all times a minimum of 16 gigs of memory, no matter what. Right? That 16 gigs is permanently and consistently set aside for only that resource pool, and nothing else can use it. And so I can dedicate a certain amount of physical memory strictly to a resource pool. And a VApp is very similar. Right? A VApp is very similar to a resource pool. Again, it's a container that we can put multiple virtual machines in, and we can control shares, limits, reservations, permissions. We can do all of those things that we just saw with a resource pool. However, the big difference between a VApp and a resource pool is that a VApp is largely intended for multi-tier applications in which we need to control boot order. So for example, in this scenario, let's say that I've got this website that requires a database on the back end. So on the left-hand side, we see my DB virtual machine. And then we've got an application server that kind of runs in the middle. And then we have the actual web server that's presented the web page to my end users. And so in this scenario, I know that for my application to work properly, the database virtual machine has to boot up first. And once it's ready to go, then the app virtual machine can boot up. And then finally, and third, the web VM should boot last of all. You can control this boot order with a VApp. A VApp can be used to specify the boot order of the contained virtual machines so that you know that these three VMs will always boot in the correct order. Okay, so in this lesson, we learned how resource pools can be used to group together multiple virtual machines and provide resource pools like shares, limits, and reservations. We can also apply permissions and alarms at the resource pool level. Our ESXi host itself is referred to as the root resource pool. That's where the actual physical resources come from. And we can also even create a child resource pool within a resource pool.